Hi, this is Unit 4, Free Question Set B. Question 1, no calculator is allowed for this question. I actually videoed this already, but it didn't save for some reason, so I'm going to start it all over again, which is why I have some information written on here already. So the problem starts right here, and we talk about the depth of a river at a certain point is modeled by the function W defined above, where W of t is measured in feet and time t is measured in hours. So a lot of times when I have these types of problems, I'll kind of label my a function so I know what it is that it's finding. So W of t is finding the depth of the water in feet, and two different time domains here. We have a piecewise defined function, and time is measured in hours. Part A will be worth 3 points, part B will be worth 4 points, and part C is worth, I didn't write it on there, but it is worth 2 points. All right, so part A wants you to find W prime of 8. I'm going to put this off to the side and have to use the paper because I've written on there already. So for part A, we know that W is going to be, now because we want to find W prime at 8, we're going to have to use the bottom piece of that function because that's where the domain of 8 is. So W for this part is 10 minus 1/5 of a t minus 6 squared. When we find that derivative, W prime, derivative of 10's gone, this 2 comes down, so negative 2/5 times t minus 6 to the first, and then times the derivative of the inside. Do you have to write that times 1? No, I do, just so I remember that I've done everything that I'm supposed to do. Now we can find W prime of 8. So negative 2/5 times an 8 minus 6 to the first, negative 2/5 times 2, which is negative 4/5. There's your W prime of 8. Okay, now they did also ask us for this one to explain the meaning of W prime of 8 in context of the problem and using correct units. So we did a derivative here, and this found depth of, W was depth of water in feet and time, so we are finding how fast the depth of the water in the river is changing at time 8 hours. So if we write that out, we will say that the depth of the water in the river is changing at a rate of negative 4/5 feet per hour at time equals 8 hours. Okay, now definitely instead of changing here, you could have said decreasing, and then you would have written that as a positive 4/5. You just can't say decreasing at a negative rate. Okay, point values here for this one, that was 1 point to get the W prime of t, 1 point to get the W prime of 8, and 1 point for interpretation with units. Okay. All right, part B. Part B is actually kind of long, so I'm going to need a whole piece of paper for part B. All right, part B, when we look at this, it says the graph of W is concave down for t between 3 and 3.5. Use the tangent line to the graph of W at t equals 3 to show that W of 3.5 is less than or equal to 9. All right, So use the line tangent to the graph of W. So we got to find the tangent to W at time equals 3. All right, so if we set this up, W minus something equals slope times T minus, all right, they told us time 3, so we've got that. Right here, this is going to be W of 3. So let's look back at the W equation. Time 3 is going to go into this top one, so I'm going to have to plug a 3 into that top piece. And that's going to be 17 halves minus 3 halves cosine pi t, so 3 pi over 6. 17 halves minus 3 halves cosine pi over 2. Pi over 2 is up here. Cosine there is 0. So we have 17 halves minus 3 halves times 0, or 17 halves. There's that value. Now here, that's slope, so that's going to be W prime of 3. Be very careful here because you found W prime already in part A. We found it, it was right here, but that W prime is the bottom half. So because we're looking at this for the time 3, we need to do the derivative of the top piece. So right in here, let's find W prime of T. The 17 halves is going away, and then the negative 3 halves stays, and then the derivative of cosine is negative sine. Leave the inside alone. Pi t over 6, and then times the derivative of the inside, which would be pi over 6. I'm going to simplify that. Let's see, it's going to give me a positive 3 pi over 12 sine pi t over 6, which is pi over 4 sine pi t over 6. W prime of 3 is going to give us pi over 4 sine 3 pi over 6, which is pi over 2. Pi over 4 sine pi over 2. Sine of pi over 2 is 1. So W prime of 3 is pi over 4. Okay, so looking back at this question, part B, the graph of W is concave down. Use the line tangent to show that W at 3.5 is less than or equal to 9. So first thing that we're going to need to deal with is this concave down. How does that relate in here? And because W is concave down on that interval, then the tangent line is above the actual curve. Let me write that down so you can kind of think about it. Since W is concave down on that interval from 3 to 3.5, the tangent line will be above the actual curve. Now, I want to talk about this even though it's not specifically part of this problem, but I just want to explain to you why with that. Just, yeah. So if you think about something that's concave down and increasing or concave down and decreasing, any tangent line that you put in here is going to be above the curve. So if you estimate some value or use that tangent line to estimate a value, your estimate is always going to be an overestimate. It's going to be larger than the actual function value. So we're just going to kind of complete this off. Since W is concave down, the tangent line will be above the actual curve, and any estimated value from the tangent line is larger than the actual value of W. Okay, now they're specifically asking you about the W evaluated at 3.5. So let's use that tangent line because it says, part B, use the line tangent to show that W of 3.5 must be less than or equal to 9. So let's go with using that line. W of 3.5 is approximately, now I'm going to use that line, so I'm going to take my line here and I'm going to plug in 3.5 for time. So pi over 4 times 3.5 minus 3, and then I'm going to take that minus 17 over 2 that was on the other side and move it over here, plus 17 over 2. So W at 3.5 is approximately pi over 4 times a half plus 17 halves. So we're going to have pi over 8 plus, this is 8 and a half. Okay, now how big is pi over 8? Well, pi is 3.4, roughly 3.2, just because I can divide 3.2 divided by 8 pretty easily. That's 0.4, but pi over 8 is really going to be less than 0.4. And this is 8.9. So this is saying that your estimate is roughly 8.9, but that estimate is an overestimate, so the actual value is less than 8.9. This estimated value is an overestimate the actual value of W of 3.5 must be less than that. Less than 8.9, which is less than 9. So W of 3.5 is less than 9. Okay? Values here. What are you getting for this? You are getting plus 1 right here for W prime of t. You are going to get plus 1 for W prime of 3. You're going to get plus 1 for the explanation. And you're going to get plus 1 for the estimate. Okay, realistically, it's tough because you want to get these problems 100% correct, and you're not going to, and that's okay. Don't panic about that. It doesn't mean anything bad toward you or anything. It just, you're not going to get the full points. And you kind of have to learn to live with that and accept that's going to happen. The average score on an AP test is, on a 9-point problem, is between 4 and 5. So you're aiming to look and get 4 points here. If we look at this problem reasonably, you should have been able to write the equation of the tangent line. So you should have had 2 points here. And then if you think about what they told you about the concavity and that it's an overestimate, you could get that third point. This one might have been tough to come up with just because of the estimating here and coming up with that really is less than 9. So I think that would be kind of tough to do. Okay? Let's look at the last part here, which is part C. And part C says, find this limit as t approaches 2 of w of t minus t cubed plus 1/4 all over t minus 2. So, important thing here is to recognize that you're going to have to figure out this limit. So, kind of all over the place here. I'm sorry, I have so many pages all over. So, oops, not D, C. We want to find the limit as t approaches 2 of w of t minus t cubed plus 1/4 all over t minus 2. And the very first thing that you do when you evaluate a limit is that you plug in. Plug in t is 2, and that's going to give us w of 2 is 2 cubed plus 1/4 all over 2 minus 2. And right there, that's given us a problem that we got a 0 on the bottom. We do need to think about this numerator, whether it's a number or whether it's another number, not 0, or whether it is equal to 0, because that'll lead us in two different directions. So let's find this w of 2. Now, the 2 is the top piece, so plugging that in, that's 17 over 2 minus 3/2 cosine of pi t, so 2 pi over 6. 17 over 2 minus 3/2 cosine pi over 3. Pi over 3 is right here. Cosine there is 1/2. So this is 17 over 2 minus 3/2 times 1/2. 17 over 2 minus 3/4. Common denominator makes this 34 minus 3/4 or 31/4. All right, let's take that 31/4 and plug that up here. So that's 31/4 minus 2 cubed is 8 plus 1/4. Okay, let's see, this 8 is negative 32/4. So we have 31/4 minus 32/4 plus 1/4 over 0, which is 0 over 0. There is one of your indeterminate forms to use L'Hopital's rule. So now we have to apply L'Hopital's rule, which says we're going to do the derivative of the numerator over the derivative of the denominator, not quotient rule, but just derivative of the numerator and denominator separately. Same limit as t approaches 2. I started to write an infinity there, I'm sorry. This is going to be w prime of t minus the derivative of that t cubed up there is 3t squared. The derivative of the 1/4 is 0. All over derivative in the bottom is 1. Hey, and that's nice because now I don't have a 0 in the denominator, so that's a good thing. So now we plug in the 2, and that's going to give us w prime at 2 minus 3 times 2 squared all over 1, and that's going to give us a minus 12 here. Now we need to find w prime of 2. So being very careful, which w prime do we want? And because we're looking at t is 2, we want the w prime of the top piece. So I'm going to go find where I did that. W prime of 2. Here it is. Here's the W prime. It was on part B. It's the W prime of the top piece. So it's right there, pi over 4 sine pi t over 6. W prime of t was over 4 sine pi t over 6. W prime of 2, pi over 4 sine 2 pi over 6. Sine of pi over 3 is square root 3 over 2. Oops. Times, which gives us pi square root 3 over 8. Whew, that's this. Pi square root 3 over 8. And that is an ugly answer to a limit, but it is the answer. Okay, where do we get points? You get 1 point for recognizing and applying L'Hopital's rule. And you get 1 point for the answer. Okay, now, again, they're not going to hit you up for numerical simplification. So you could conceivably write W prime of 2. You could have written pi over 4 sine 2 pi over 6 minus 3 times 2 squared. That would be an acceptable answer. You do not have to simplify. Okay, thanks. Let me know if you have any other questions. Talk to you later. Bye.